In going over this problem on 2D kinematics, remember that you do not need to write down all the work. The problem and all of this video will be on my website. What you need to be writing down is your 4x6 card that's going to go into your flip chart. So write down what's going to help you get 2D kinematics problems in general. And I'm going to try to say things as I go that will help you to figure out what you should put in there. So this first problem, 2D kinematics, uses the same kinematic equations that we did for the first one. We used them a lot, but make sure that all four of those are on that note card somewhere first off. And then write down a quick series of steps that will help you to do these. On this first one, it says a monkey has a coconut on the top of a cliff of height h. If she drops the coconut, how long will it take to reach the ground? So I know that V1 equals 0 when you drop something. And so there's certain special things, like when you drop something, when it gets to the top of its arc, when it gets to the same height, make sure you write those things in on your card. I know that the distance it's going to fall is negative h. It goes negative because it starts up high and falls down. If I have my cliff, it starts below where it ends up. And then I know that the acceleration is negative g, and I'm trying to find time. I want to put all four variables over there on these so that I can quickly find which equation it is. I find the equation d equals v1t plus 1/2 at squared, and then I plug everything in that I know. This becomes negative h, this whole term becomes 0, this is negative g, and I'm looking for t squared. Cancel out my negatives because I multiply both sides by -1. I take the 2 and the g to the other side, so I get 2h divided by g equals t squared. And I end with t equals the square root of 2h over g. I did a really quick one with variables here. The rest of it's with numbers, but this variable, finding the time when the initial velocity is 0, appears on every AP test as variable. So this is something that maybe you should put on your card as well, and be familiar with that. And this can be if it has an initial velocity just in the y direction 0. If you have an initial velocity here, the x, all in the x, you'd still use this particular equation. On the second one, we give it an initial velocity that is 10 meters per second at an angle of 30 degrees above the horizontal. Whenever we have an initial velocity that's not in the x and y directions, we have to separate it into v1x and v1y. Using sines and cosines, it's always the hypotenuse times either the sine or the cosine. If it's the adjacent side, we know this has to be cosine of 30, and this has to be sine of 30. Oh, sorry, 10 sine 30. And so when we do that, 10 cosine 30 is 8.66. 10 sine 30 is 5. So then we set up an x column, and we set up a y column. And I like to leave space to do my work next to them. On the x side, I throw v1 equals 8.66. I know that v1 on the y side is 5. I know that the acceleration on the x side is always 0. That should be a note card. Acceleration on the y side is always negative 9.8, unless there's some added acceleration, and usually they don't do that to you. I know then also I'm going to the top of its flight this time, and remember the special situation for top of its flight means that it's y v2 equals 0. So then I know I'm trying to find how much time it takes to get there. So I'm looking for a kinematic in the y direction that has v1, v2, a, and t. So here's a different kinematic. v2 equals v1 plus at. 0 equals 5 plus negative 9.8 times time. Or I could put 10 in there. This one 10 ends up being a lot easier, so I might do that. I take this 5 to the other side. It's negative 5. But since I have a negative there, I'm going to cancel both those out. So I say 5 equals, and I'll make that 10 because it's easier in this case. And so my time equals 0.5 seconds. I have the second one done. For part C, also going to 2D, I'm going to put my columns again. I have an X column, I have a Y column, leaving space again. I still have my V1 equals 8.66, my V1 equals 5. My acceleration here is 0. Acceleration here is, let's go with the 10 now, because since I said that, let's go with that, it's easier. Then I know that on the y side, I have a displacement of negative 50. In the x side, I want to find my displacement. Because for this one, they're asking how far from the base of the cliff. That's dx. They're telling me that is 50 right there. So, I want to find that, but I don't have enough information there. I always go to the side where I have three things, I can always find a fourth. In this case, time is the one that will transfer from one side to the other. So what I can do over here is say, I want an equation that has those four variables, so I use d equals v1t plus 1/2 at squared. And I, negative 50 equals 5t plus, and that's, I'm going to say that, call that 10, so half of that is 5t squared. That's a nice thing because I can divide it all by 5. Sorry, that's a negative 5 there. But other than that, I have to use a quad form, so it's not a great problem. But I'm going to divide by 5, so I get 10t plus negative t squared. And so then I say 0 equals negative t squared plus t plus 10. And there's a whole bunch of different ways of solving kinematics. But this one, you could put it into quad form if you remember that. But we could just solve this one by factoring, right? So we could say t